In this video, I'll be doing a simple Boyle's Law investigation. For this experiment, we'll be using the 850 interface to collect data from all our sensors. And we have here a pressure sensor, which will be connected to the heat engine apparatus to track the pressure as the piston is compressed. In order to track the movement of the piston, I will be using a rotary motion sensor with a mass hanger whose mass is equal to that of the piston, suspended over the largest pulley. I'll go over that in the software a little bit later. So with that, let's go ahead and get this set up in Capstone here. And let's open up Capstone. All right. So what we're gonna do is we're just gonna do a simple table and graph setup. So I'm just gonna drop a table right over here and a graph right over here. And so we want to compare the pressure and volume of the system. So let's go into our hardware setup, make sure everything is connected. Great. And actually, let's go into the settings on the rotary motion sensor and verify that we are, in fact, measuring along the large pulley. Make sure this is set to the pulley you'll be using. You can use whichever you like, but I just have it set for the large one. I'll hit OK. So we're going to need 3 columns of data. One, we want the pressure. So we have right here our pressure sensor. Make sure it is connected to the heat engine apparatus beforehand, and ensure that the piston is raised all the way up before setting this up. And then we want to track the volume of this piston. So we actually need to make a calculation for this, because we want to monitor the change in volume as we're compressing it. So we'll say volume is equal to, so we want to first find the volume of the entire cylinder when the piston is all the way up. And I already calculated that ahead of time, and that's about 65.54 milliliters. And so now we want to subtract from it the displacement caused by our compression. And so the equation for that is simply just the volume with the changing height. So we need to subtract, make sure you use parentheses. We're going to do pi times, the radius of the piston is 16.25 millimeters. So we're going to do 16.25 squared. In this case, I'll just do multiplication twice. And then multiplied by the position measurement read by the rotary motion sensor. So we click on this little colorful triangle and we select the position. And we need to make sure this is in millimeters. That's everything we're basing it off of. And then we need to divide this whole value by 1,000 to put that unit back into milliliters. Oops. 1,000. And close the parentheses. And so that's our volume calculation for that milliliter. And then we're going to make one more calculation just to compare the product of these two values to make sure that Boyle's law is in fact true and that they are consistent throughout the measurement. So we'll just call this PV is equal to the volume that we just created multiplied, multiplied by the pressure. Units are arbitrary. We're just looking to confirm that the values are in fact the same. And we'll go ahead and close this. So we have pressure, volume, and the product of the two. So let's put volume here on our x-axis and put pressure on our Y. And we're going to set up a recording condition here because we are constrained between 100 and 120 kilopascals of pressure. In order to get good measurements outside of that, values start to deviate. So let's go ahead and create a recording condition, a stop condition, measurement based. And once the pressure is above 120 kilopascals, it'll stop data recording. So where I'm at right now, we are already at a standard pressure of 101 roughly. So we have very little room for recording. So when we're compressing the piston, we're going to be doing it in a relatively slow, smooth motion. It's not going to be super fast, but also not super slow. So let's move that out of the way. Let's make sure this is all the way up. All right, I'm going to hit record, and I'm going to press down on it firmly. And so what we can see is here we have the product of every single data point. You can see how close they are to each other as we scroll down here. Once we start getting past the 101 that we initially started at, values are within 1% of the of deviation of each other. If we apply curve fit, there's not a lot of data here, so it's not likely you're going to clearly see that inverse relationship, right? But it will give you a curve, and this is a relationship we are expecting to see when we verify Boyle's law. But we can also look at it mathematically right here and see that it does in fact work.